So everybody has 2.6 notes in front of them. Is that correct? All right. Guys, pretty easy stuff today. I think if you just follow the rules, you'll be in good shape. But 2.6 is going to start looking at how do we compare inequalities to absolute value expressions. And essentially what we're asking is this: how can you solve an absolute value inequality? We're not going to spend a ton of time on this. I think once you get the gist of this, you'll be in good shape with it. I'm going to show you kind of a cheat sheet to help you make decisions on this, and it should help out quite a bit. But goals today, we want to look at what solving absolute value inequalities looks like, and then we're going to use those absolute value inequalities to solve real life problems. Guys, remind me again, absolute value, we said an absolute value can never be what type of a number? Negative. Solutions could be negative, but we're saying that if you look at something into expression, you have those bars. No matter what, in the end, if you take an absolute value of something, it either has to be positive or what value? Negative. Positive or 0. Can absolute values ever be negative in the end? They cannot. Okay, I'm going to show you some things graphically that might help you out as well. But guys, let's just jump right into this. First of all, vocab-wise, I'll volunteer to read that first one for me right there. What an absolute value inequality is. Roll, Emily.
An inequality that contains an absolute value expression.
So an example of this might be the following. Something like, give me the absolute value of an expression, somebody. Absolute value of what?
13.
13. Throw a variable in there somehow. Plus x. How's that sound? And we'll say maybe greater than 20. All right? Absolute value, inequality sign, that's all it is. All right? Guys, and the second thing we're going to kind of discuss today is what absolute value or absolute deviation means in terms of inequalities. What it says right here is absolute value of the difference of a variable x and given value. You guys remember in chapter 1 when we looked at absolute value functions, remember if I said you have a minimum of maybe 10 and a maximum of 20, I said write an absolute value equation for those? Remember we took the average of the endpoints, 10 and 20? What is the average of 10 and 20? 15. So in the absolute value part, we would have x minus 15. How far does 15 deviate from the endpoints?
5.
So I would say x minus 15 in an absolute value function equals what value? 5. So you might want to write that formula down again, because that's basically what we're going to be applying here. We're just going to put it in inequality form. So you might want to just jot down, hey, don't forget this, x minus the average was equal to, what I'm going to call it is the deviation. Deviation meaning how far is the average from the endpoints? Okay? How far is the average from the endpoints? So recall that formula right there. All right? You guys remember seeing something like that last chapter?
Yeah.
All right. Well, guys, let's take a look at this next problem right here. I want to know what it means to solve absolute value inequalities. We're going to kind of explore this together, and then I'm going to show you the rules. But what I'd like to first do is just get some thoughts on this. And the first question I have right here is the following. On a number line right here, what does the absolute value of x minus 3 greater than 5 look like on a number line? Okay? We spent a lot of time in the last section talking about this. You don't need to write this down. Just follow me. If I have a number line right here, and maybe this is open and this is closed, so I have a half open situation here, and shaded in between like that. Let's just put some values with this, like maybe -4 and +31. Kids, is that an interval or is that 2 infinite intervals? It's an interval. There's a start and a stop to it, right? So in which case I could write the following inequality: -4 less than x less than or equal to 31. You guys agree with that from last section? That's how I would write an inequality to represent that interval. Okay, well then secondly, we also have situations that look like this. Might have a number line. Might be open on -4. You might be closed on 31. But maybe your shading looks like this. Maybe you're going right of 31. And maybe you're going left of -4. So in that case right there, guys, how do you write an inequality for that, or a compound inequality for that? Well, first thing you would say is x is less than what value? X is less than -4. But I use and or as a conjunction here. Which one? Or x is greater than or equal to 31. Although the word isn't listed up here, what conjunction is implied in the red graph? This is x less than -4 or x greater than 31. What's implied up here? And is implied, right? This is satisfying both conditions at the same time. This is saying you just have to satisfy one of the two conditions. So let's go back to that front-loading question here and say, all right, what does this look like graphically? Well, let's talk about it. Maybe the better question I need to ask here is the following. What values of x might work here? Can you think of a value of x that you could substitute in that would work? And the absolute value of x minus 3 greater than 5. Can you think of a value of x that would work here? 10. 10 works. Because 10 minus 3 is what value, guys? 10 minus 3 is 7. Is 7 greater than 5? Or the absolute value of 7, is that greater than 5? Okay, so 10 works. I'm gonna plot that. That works. Any other values that work? Let me ask this question. Where in the world is the x minus 3 even equal to 5 at? Where in the world is x minus 5 equal to 3? 8 works, right? Because 8 minus 3 is what? 5. Okay? So I'm going to put a circle here on 8. You know, keep in mind, this x minus 3 is what kind of x minus 3? Well, it's an absolute value of x minus 3, right? So when I plug 8 in there, the 8 minus 3 is 5, but more importantly, the absolute value of 5 is still what as well? 5. Okay? Guys, is it possible that -5, or the absolute value of -5, would equal 5 as well? Would that work? You guys agree with that statement? Okay, here's a question then. What negative number could you throw in here? In other words, some number minus 3 would make a -5. Wouldn't that be -2? What's -2 minus 3, guys? -5. But the absolute value of -5 is what other value? 5, okay? So I'm going to circle the -2 here as well. Now, guys, here's the deal. Those are the parts where the graph is equal to 5. Who offered me a solution of 10 already? Okay. The parts that I circled up there, the -2 and the +8, are values where we would be equal to 5. And I left them open simply because your sign is greater than, not greater than or equal to. Okay? Guys, when Tori said, hey, 10's a solution, when I throw 10 in, we get a true statement. How is 10 related to that end point right here where 8 was a value equal to 5? Is that point to the right or to the left of that point? Okay, what it implies that everything to the right here is going to be a solution. So does this look like a compound inequality where you're going to be shading to the inside of the points or to the outside of the points? Well, based on what I have over here, it looks like to the what? Inside or outside, guys? Outside, all right? This looks like the solution to the following is going to be x less than -2 or what? What do we see over on the other side? X greater than anybody? Greater than 8. Okay. Now that's kind of hard just to come up with on your own. Some of you are probably looking at me like, ooh, I don't know what you just did there, but I'll agree with you. What I want to do is I want to show you how this stuff works, and we're going to come back to that and check out some of our rules with this to see if this does work. But let me ask this question, guys. If I pick a value over here in a shaded region, like say -10, guys, what's -10 minus 3? -13, right? -13, and then is the absolute value of -13 a +13? So when I plug that in right here, is that +13 greater than 5? So do these shaded values work to the left? Okay. And we already know 10 works, so everything over here is going to work, all right? Now, let me show you the rules here. Why don't you jump into page 2 quickly. Rules for solving absolute value inequalities. And we're going to apply it right back to that front-loaded question here in a second, but here it is. Somebody have a question? Oh, it's on the first page? Ooh, what happened there? All right, well, good enough. Do you guys have all, tell me it all went to the first page.
You just have to know.
Okay, so it kind of wrapped around 2 pages, right? All right, that's okay, because the front side is if it compares to a positive, the second side is if it compares to a negative. What I'm going to tell you is this. On the top of your second page, highlight that stuff or point it out or whatever. And I don't care what you do, just know that this is very important. Okay, so at the bottom of your first page, really the top of mine, it says rules for solving absolute value inequalities. Okay? First rule I have up here, guys, compares the absolute value of an expression less than a what kind of value, guys? It says less than a what? Positive. Next one compares the expression but not less than but greater to a what? Positive. Then we start comparing stuff to negatives as well. And isn't that part on the top of your second page right here, the negative part? Okay, so just know it back and forth. Maybe that's kind of a good thing because it kind of organizes it so that you have positives on one page and negatives on the other page. Okay, let's just read through these rules real quickly. That first rule says if the absolute value of any expression is less than a positive or 0, what's the rule on the right say to do? Well, it says set the expression less than the positive and then set the expression greater than the, remember in absolute value equations, how many equations were you always writing to solve those? You had what you started with equal to the original, what you started with equal to the opposite. We're doing the same exact thing here, okay? So in this situation right here, I'm not going to read through all the rules. What I need to ask myself is which of these rules, and I'm going to put numbers to them, and you might want to do the same. And you don't have to flip back and forth. You can just refer to mine. And I'm going to jump right down into these examples to try this. But in example 1, and understand this too, when you have absolute values, the only thing you want on the left side or the right side, the absolute value has to be all alone by itself. And I'll show you one where we have to manipulate some things here in a bit. But your absolute values always have to be on one side of the equation, everything else to the other side. So as I look at my rules, 1, 2, 3, and 4, we've got to make sure that we're satisfying these conditions. So in example 1, solve and graph each inequality. Check this out. I have the absolute value of x plus 3 less than or equal to what here, gang? 2. Okay? So based on this right here, first of all, the value I'm comparing the absolute value to, maybe the first question I should ask is the absolute value all by itself? Is there anything to the outsides of the absolute value on the left side of the inequality that we need to move first? No. So is the absolute value all by itself? You're going to say, yeah. I'm comparing an absolute value to what kind of a number over here? Positive, negative, or 0? Well, we're comparing it to what value here? Positive 2, right? So we're comparing to a positive 2. So guys, which of these conditions am I working with? 1 or 2? Is the absolute value of the expression less than a positive, according to what's written, or is the absolute value of the expression greater than a positive? Well, what sign is here? Less than or equal to. So that condition 1 or condition 2? Rule 1 or rule 2? 1, right? Rule 1. Okay, so I'm going to write this down. Use rule 1. All right, so here's how you're going to solve this. You ready to roll? Here's how you're going to solve this. It says, whatever you had the absolute value of in the expression, take that expression from the inside. So do I want to keep the bars or get rid of the bars right here? Are there any bars around the word expression here? No. Absolutely not. So write it as this. Here's how you're going to solve this. You're going to take x plus 3, set that less than or equal to 2. Basically, you're just writing the original problem out without absolute value. Now the second part of this, it says also take your expression, change less than to what here? Change less than to what? Greater than, and then compare it not to the positive, but to a negative. In this case, negative what? So the other thing you're going to write is your expression, x plus 3, less than or equal to shall become greater than or equal to. Good. And then instead of positive 2, you want what? negative 2. All right, let's see what we get here, kids. Let's see what we get. This first one that we solve, just tell me what's my process, guys. Okay. Subtraction won't change my direction of the sign, so this will be x less than or equal to what, guys?
-1.
You okay there? How about my next one? Same process. What are you doing to both sides?
Subtracting 3.
Okay. What am I going to end up with here? What am I going to end up with here? X greater than or equal to -5. All right, so here's what I want you to get down and understand here, okay? This is really what I want you to understand, and pay attention to this because this is also very important. First of all, I'm going to put my points up here. It looks like -1 and -5, so I'm going to call this a 0 right here. Whoops, I didn't want to do that. Call this point, this calls a 0, -1, -2, -3, -4, -5, -6, like so. Right? You guys okay with that? Yes or no? Okay. What values am I referencing? What values am I referencing here? So -1. Open or closed on -1? And how about -5? All right. Everybody agree with the endpoints here? All right. Now, graphing is going to be very important for you in terms of how do you write your solution and when. Do you write it as a compound inequality using the conjunction and, or do you write it using the compound inequality using the conjunction or? Guys, I want to be less than -1 but greater than -5. So if -1 is here, where's less than it? Well, to the what? To the left, isn't it? And I want x to be greater than -5, and that's to the right. So am I shading outsides or insides here? Insides. Okay. So the question I ask myself is, hey, this an interval, or is this a situation where you have 2 infinite intervals? What are you going to tell me? What are you going to tell me? It's an interval, okay? So this is what I want you to get in the habit of, writing your solution the way you're supposed to in terms of compound inequality. So the solution to this, I agree, this would be an and. So to express or imply and in this, what's my minimum value over here, guys? So the way you're going to write this is as follows. The solution to this will be -5 is less than or equal to x is less than or equal to -1. That would be your solution in compound inequality form from last section. A lot going on there, but if you follow the rules, it's pretty easy, isn't it? A lot going on there, but if you follow the rules, it's pretty easy. Let's try another. Let's just solve this one without even graphing it. First question, absolute value all alone? It is, isn't it? We're in good shape. So are we comparing an absolute value to a positive or to a what? Comparing it to a negative, okay? Are we saying the absolute value is less than a negative or greater than a negative? What's the inequality say? Less than or greater than? Okay. You guys have been told that when you take the absolute value of something in the end, it can never ever be what in the end? Negative. Well, guys, if I have an expression right here that says, hey, I want this mess over here, which will never ever be what kind of a number ever? Negative. Never be a negative. We want it to be less than another negative. In other words, we want it to be more negative. Is that going to work? It's not. It's not. I've given you the rules. I've given you the rules. Check it out. Up top. Boom. We are taking the absolute value of an expression less than what kind of a number? Well, this chart says what? There is no solution. Because no matter what you pick for C, guys, no matter what you pick for C, I don't care if you pick a number so big or so small, When you take the absolute value in the end, it's either going to be positive or what? 0. If this number here is positive or 0 in the end, that's not the word 2, that's positive 0. Okay. I asked Terrell Owens what his initials were. He said positive 0. All right. Anyway, get it?
No.
Terrell Owens, his nickname was T.O. when he played football. I asked him what his initials one day were. He said his initials were positive 0 instead of T.O. Never mind.
You really say that?
Oh yeah. T.O. and I were like this. If this is positive or 0, will it ever be less than negative 2? No. So what's it saying up here, guys? Anytime you compare to a negative number, you're going to be in a situation where you have what? If I switch the sign around, instead of having a less than, and you say, oh, it's greater than a negative, isn't a positive or 0 always going to be greater than a negative?
Yeah.
Comparing stuff to negatives is nice, because your answers are either no solution or many solutions. Guys, if you follow the rules up here, you cannot screw this up. You cannot screw this up. In fact, I'm going to take this a step further. Okay? Anytime you're comparing an expression less than a positive, you're always going to use the conjunction and, which is going to imply an interval. And anytime you compare an expression greater than a positive or 0, this will always be some kind of an or statement. Okay, so you might want to jot those words in there. In fact, I'm just going to write down that this is an interval. Guys, if I put 2i in there like this, you understand that means 2 infinite intervals? How about I write this way? Your graph is going to look like this. Is that better? Yeah. Okay. Thanks, can you smell my feet? Good. So I don't feel like wearing shoes today. All right. Let's move. Any questions so far? All new stuff, but are you following the rules right here? All right, let's try another one down here. Here we go. What are you going to say about this then? Tell me which rule you're using and what's the solution. Yep, for B. The absolute value compared to a negative. Furthermore, less than a negative. No solution. No solution here. You understand how to read the rule chart up there, guys? Good. No solution. All right. Let's try some more. All right. Take a look at your rules. We're comparing to a positive right here, guys. Comparing to a positive. It's going to be an or. Okay? Going to be an or. So here's how you solve this. You take the x plus 1, set it greater than or equal to what first? Well, greater than or equal to 3. Then you're going to take your expression, the x plus 1. Let's switch the direction of the sign. So greater than or equal to will become less than or equal to, but not positive 3 anymore. What do you want there? Negative 3. Here's how we solve this. Subtract 1 from both sides. You agree? So on this one right here, you're going to end up with x greater than or equal to what? 2. And here you're going to end up with x less than or equal to negative 4. So I'm going to choose 0 to be right here in the middle. Call this 1, 2, 3, 4. We'll go negatively. Well, you guys get the idea. On the negative 4, will I be open or closed? If there's 0, 1, 2, 3, 4, so closed on negative 4 there. And then I'll also be closed on what other value? 2. Guys, this says graph all x values greater than or equal to 2. So if I want to be greater than or equal to 2, am I going outside of this or inside of the other one? Outside. So you're going to shade to the right. So solution-wise right here, the only way I can write my solution for this is to include the conjunction or. So my solutions, x greater than 2. I'm sorry, x greater than or equal to 2. Or x less than or equal to negative 4. What do you guys think? Are we cool with this? I'll wait till everybody has that down. See if there's any quick questions. We'll roll through B, C, and D. Have you tried them here? Okay, in part B of your rules 1, 2, 3, and 4, I already know I have to run number 3 and 4 without even looking. Why do I know I have to run to 3 and 4? I'm comparing an absolute value to a negative, right? In this case, greater than a negative. You said all absolute values in the end will be positive or what? Positive or 0. How do positive or 0 in this case? Are any positives or 0 always going to be greater than negative 5 here? So how about my solutions here? None or many? Many. That's all I need to say. Many solutions. Part C then. Part C. I have an issue with this. Part C is a biggie. Make sure you understand this. First of all, can I work with the problem the way it's written, or are there some problems here? What are the problems? Is the absolute value all by itself on the left side? We've got to make it that way before we can work with it. So I've got to rewrite this one. So you might want to write down that, you know what, before I can proceed with this, you have to rewrite the inequality. So to rewrite this inequality, I see the absolute value part here in the middle, but there's a -5. What should we probably do to both sides? Better add a 5 to both sides. All agree? Yes. So I'm going to have now 3 times the absolute value of 2t minus 3. If I add 5 to the 16, guys, what's 16 plus the 5 going to be? 21, right? All agree? Then my next one. Absolute value alone yet? No. There's a 3 out front. This says 3 times the absolute value. So what do you guess you're going to have to do now? Divide each side by just the 3. Divide by the 3. 3's will cancel. Bang. So now when I rewrite this, we're to the part where we have absolute value, 2t minus 3, greater than what value here? Greater than 7. Okay. How about now if we proceed with it rule-wise? Okay, so the thing I'm going to write here is this. We're going to write down 2t minus 3 be greater than 7. What's the other inequality I would write then? Okay. So you said not greater than but less than -7. Guys agree? By the way, is this going to be an and or an or? It would be an or, right? I'll just tell you when I solve this, add 3 and divide by 2. Add 3 and divide by 2. One solution is going to be t. Help me out. What is 7 plus 3? 10 divided 2? 10 greater than 5 then. That's the first one. Second one. Add 3. Isn't that -4 right here? And then -4 divided by 2 would be, so you're going to have t less than or equal to -2. T less than or equal to . Let's see. We're going to be to the right of 5, which would be maybe right here. Maybe right of 5. Maybe right here. Then if I go by ones, 4, 3, 2, 1, 0. -1, -2 would be closed on -2. We would have to shade right of 5 because we want t values greater than 5. We would have to shade the left of this right here because we want values less than -2. So can I write this in interval form, or do I have to throw the word or in there? Whoops, I grafted on the wrong one, didn't I, guys? Yeah. Oops, I can fix it. Fix it, Felix. I can fix it. Oops, what? You have never seen Wreck-It Ralph? Who hasn't seen Wreck-It Ralph?
I haven't.
That's a great movie. I love Wreck-It Ralph.
What? Yes.
I just want a medal. I just want a medal. You kind of get the idea, don't you? This 5 should be up here. You understand that's 5, right? Okay. So I understand my solution right here. Okay, check the next one out. Again, we're comparing absolute values to be, I want to look at something. I don't know if I made a mistake. Oh, nope, I'm fine. How about this one right here? Absolute values alone less than a negative. Comparing to a negative, we want numbers to be less than a negative. In the end, no solution here on this one. Okay? No solution. Make you a deal. I'll make the assignment even shorter today if you decide to get all 4 of these problems right on the next page. Anybody have questions so far? Yeah.
How come the 2 is
Because when you rewrote this right here, did I put equal sign in there? I didn't mean to, did I? This should be just less than right here. Thanks, Tori. You caught me. First mistake I've ever made, you know that? I never tell a lie. I might bend the truth from time to time, but I never lie. That should just be a less than here. So this should actually be open. Let me fix this up. I don't like the way this looks. This looks boring. Let me fix it. My solutions for that one should be the following. It should be, what do we say, t less than -5, is that right? -2, right? Or t greater than 5. Okay, so that would have been a solution. All right, hey, last page here quickly. Guys, you have some on your own problems there? You have some on your own problems there? Okay, I want you to try those 4 right there on your own. So go ahead and do those quickly. Once you've got those figured out, check with the neighbors, see if you guys agree. When you've got those 4, check with the neighbors, see if you guys agree. All right, guys, and this one right here, am I comparing to a positive or a negative, first of all? Positive. So I need to set the x minus 4 greater than 12 first. Whoops. Okay, and so in which case, what did you guys get there? X is less than or greater than 16. How do I have that? Am I going right of 16 or left of 16? Right of 16. So imagine right of 16 first. Okay, and my next one right here, I would set x minus, hey, where did that go? I would set x minus 4 less than what? Not positive 12, but negative 12. What'd you guys get there when you add 4 to that? Okay, can you guys imagine x less than -8 going left and x greater than 16 going right? My minimum's over here, my maximum's over here, so is this an and or in the end? This is an or, right? Okay, so solution-wise, the way I want you to get used to this, or what I want you to be able to do, is write this as follows. I want you to write this as the following. Whoops, I did not want to do that. Come on. This is what I want to see in the end. I want to see I want to see x less than negative 8 or, whoops, x less than negative 8 or x greater than 8. Can we handle that? I'm sorry, 16, right? Isn't that what you guys came up with? Okay. Now, guys, what did you get for the next one here? Who's got a solution here? I'm just going to put the solution up here. First of all, is this going to be an and or situation? This will be an and situation. Okay. Tori, what did you get for your minimum value? Negative 1.5. So this was a negative 12, right? And you add 6 to that is 6. I agree. Negative 1.5. So you should have negative 1.5 less than x less than. Okay, if you add 6 to the 12, that's 18, right? And you'll go 18 divided by 4, which is 4.5. And I write it in this interval form because of the conjunction and. Very good. Right? I like the ones that compare to negatives. Those are pretty easy, right? What'd you say about number 3 down here, or the third one, if you will? How many solutions to this? Are there no solutions or many solutions here? Many solutions here, because this absolute value will always be greater than a negative, won't it? What'd you say in the next one? No solution. Okay, very good. How many had those? How many had those like that? Okay, the part I'm really getting after here is this. I want to make sure that right here you're good with the stuff in red. Writing, if there are solutions other than many or no solution, write them as compound inequalities using a conjunction or write it as an interval where and is implied. Okay? Guys have those down? All right, last one here quickly is an absolute value deviation problem. Pretty easy. This is the one where we need to recall that formula down here. I think you kind of skipped over to your last page, and that's okay, but we kind of talked about this at the beginning. Absolute value of x minus my average is equal to our deviation. So in this problem right here, it says, you are buying a new truck. It says the table of values shows it should say trucks at different dealerships. You're willing to pay the, what's this word mean right here? Average price. You're willing to pay the mean price with an absolute deviation of at most what? 2,500 above or 2,500 below the average. It says what vehicles meet your condition. Well, here's our vehicles right here. Probably a pretty good idea if we knew what from those vehicle prices, guys. What color are they? That's important. And are they leather or are they not leather? Well, right down here, we call absolute value equations. X minus the what? Average equals my. What was my deviation in the problem right here, guys? How much am I willing to go above or below? Go. So I want my deviation to be less than or equal to 2,500. So here's the deal. What vehicles meet our condition? First thing that would be really important to know would be my average. So you guys help me punch these numbers. Let's find the average first of all. Okay, so I've got a Chevy Silverado at $38,478 plus an F-150 at $41,987 plus a Dodge Ram. Ooh, looks like the Rams are expensive, aren't they? Plus a Titan, Nissan Titan, $44,000. And then what's a Toyota's Tundra that we're looking at? What are we going to divide this by to get an average price of all those vehicles? 5 of them, right? 1, 2, 3, 4, 5 vehicles here. It looks like the average price of a vehicle is $43,800. Okay, so I'm going to jot this down right here. The average price is okay. So we want to be able to deviate from that 43,800. We're saying that's the average. We want to deviate by what value here, guys? 2,500. So what we're going to say is this. This is how this works. What you do is you take the absolute value of X minus your average, which we found to be how much? $43,800. And we want that to be less than or equal to my deviation of what value? 2,500. Be less than or equal to 2,500. Hey, does that look like something we've been solving? Does that look like something we've been solving? Okay, anytime they give you a story problem, do what you've been told to do. All right, so let's solve this. I'm going to write the work down on a different sheet. We had X minus 43,800 less than or equal to 2,500. So to solve this right here, here we go. We would say X minus 43,800 be less than or equal to 2,500. And then the other thing we would say is X minus 43,800 be, help me switch the signs around here, change less than to what? Change less than to greater than or equal to. And then not positive 2,500, but negative 2,500. Okay. So let's add stuff to both sides. On this one here, when I add 2,500 plus 43,800, what do we get for a value? So we want to find a vehicle that is less than or equal to $46,300, less than or equal to 46,300. And then the other inequality you're going to solve will be right here, the negative 2,500 plus 43,800 is 41,300. So we want our prices to be so guys, this is going to be an interval in the end. This is going to be an interval in the end. So 41,300 could be the minimum we spend that we're looking to spend. Be okay with that? Maybe that's what the banks are offering us for a loan. So the question becomes this: if that's the interval of prices that we're probably wanting to spend, 41,300 up to 46,300, take a look at your table again. Which trucks would we want to buy? 41.3 up to 46.3. Silverado. Too cheap, okay? Well, that's what I would buy. 41.3, is that Ford F-150 going to fit there? Is 41, is that price going to fit in the range we want?
Yes.
This works. How about the Dodge Ram? 46.5 was our upper value, wasn't it? How about this one? Is that going to work? Is that right? Am I out of time already?
Yeah.
Oh my gosh, have a great day. This is okay and this is not good. All right, so these three right here. Have a good day.